Get the timer started. Sound good?
All right, good morning, everyone. Thank you so much for coming. Welcome to the Redstone Composite Squadron 2025 FRR. We've been working very hard on this presentation recently, so we're super happy that you're here, and we're excited to show you what we've been working on. But first, I'm going to start with some team introductions. So my name is Christiana Berger. This is my 4th year on the team, and I work in ground station and computer-aided design, and I'm also the team captain.
My name is Cole Pirat. I've been on the team for 2 years. This is my first year on the advanced team, and I do ground station.
I'm Brody Stokes. This is my 4th year on the advanced team. I'm one of the team's technicians, as well as the safety and weather officer.
I'm Jeremy Fielding. I've been on the team for 3 years, and I'm a software and hardware technician.
My name is Eugene Park, and I've been on the advanced team for 2 years. My primary role on the team is as a software engineer.
My name is Judah Covert. I've been on the team for 2 years on the advanced side and 1 year on the basic team, and I'm a pilot.
And also one who is unfortunately not here, we have William Mitchell. He's not here because he's at basic training at the United States Military Academy. But this is his 2nd year on the team, and he worked as a software engineer and a technician. We're now going to show you our video. I hope you enjoy.
I'll pause the timer real quick.
Thank you.
You might be able to go into sound settings and then hook it up to the HDMI.
I'm connected to the HDMI.
Oh, is it?
I think that was what was playing.
All right, let's see if that works. Yeah. We'll listen.
I'll now pass it over to Cole with our system overview.
So, what a typical mission would look like is we start with our safety briefing in the morning so we can plan out what our risks are and how we can hopefully avoid them and have a safe mission. When we receive our waypoint mission, we will split. Our technicians will start preparing our hardware, our software, and our video receiver. And the mission planners will program the mission. We hope this will go smoothly because we have had a lot of practice doing this. We'll then fly our takeoff and landing for those 8 points. We'll load our waypoints onto the drone, fly the waypoint mission, swap batteries, fly search mission to identify and mark our targets, fly to the tower and identify the pickup objective first because we believe we have the highest potential for the most points when we go to the tower first because we have practiced that several more times. We'll pick up and drop off hammer, swap batteries, and load the hat into the drone, drop off the hat, return and power off the UAS to complete the mission, which should be very well since we have had a lot of practice doing this. I will now pass it on to Brody Stokes for safety.
Now let me begin by asking our team, who is the safety officer? That's right, all of us. Since safety is a top priority for our team. The four bulleted concepts above are how we manage our risks. We can mitigate them, reduce them, accept them, or transfer them. For example, if I had a brother who wanted to get into my room, I can mitigate this risk by sealing my door off with concrete so no one can get in. I can reduce this risk by changing locks on my door so a key won't work to get in. I can accept this risk by knowing my brother can get in at any time. Or I can transfer this risk by letting my parents know that my brother wants to get in my room and letting them deal with it. We can apply these same concepts to our actual risks of the mission. And we have two different categories, starting with risk to personnel. Risk to personnel includes swollen LiPo batteries, propeller collisions, and collisions with the UAS itself. Our solutions to these are handling our batteries, such as keeping them in an ammo can and constantly checking the voltage, making sure only technicians on the flight line work with the UAS and they know what they're doing, and by always having one team member with line of sight on the UAS to ensure that no collisions occur. And also with visibility, our drone has very bright green pickup mechanism legs to help us see it, and our technicians wear a highly visible orange vest, and our camera pole has orange paracord to reduce the tripping hazard. Risks to the mission include low battery voltage, losing our camera signal, losing control of the UAS, as well as team fatigue. And our solutions to combat these are a ground station can constantly measure our battery voltage. We have a 24-foot pole that our camera receivers on to ensure we have the best camera signal coverage. We have a geofence in place as well as a pilot failsafe to ensure we are always in safe control of the UAS. And to combat fatigue, since our team's been working very long days as well as late into the night, our coaches implemented a bedtime routine. Remember, everyone's a safety officer. Now on to cold development testing.
So our test plan schedule started with our pickup proof of concept. So once we designed and printed our pickup mechanism, we tested it on the ground before we tested it while we were flying. We did a lot of flight time testing, so we would test how long we could fly before it became dangerous or unsafe to not fly any longer, such as the battery overheating. We don't want that happening. We did a lot of video transmission distance testing, so we would see how far we could fly away the drone before we lose video signal. We don't want that happening during the competition because then we just can't see what we're looking for. We did a lot of manual piloting testing so that our pilot could be very comfortable with the drone and know what to do in certain situations. And we did a lot of mission performance testing, so we ran a lot of mock trial competitions so that we could get very comfortable working together as a team and working well under high pressure. Now I'll pass it off to Jeremy for software and hardware testing.
This year we've made a lot of different changes to our drone. As you can see, we have our early drone, which was our regional competition, and our new drone here. I'll show you the changes. Our main issue with our old drone was our materials. Before we're using PETG, which is very strong and mildly heat resistant, but it's also flexible. We're having problems with that during testing with our pickup mechanism of it flexing instead of picking up the hammers. We also noticed that it was too high off the ground and would get caught on the curved hammer. We also noticed that it was much heavier than we needed to fly. We also have a new pulley system, which you can see here. We added this part to strengthen the bolts and allow us to run more torque on the belts and have a stronger pickup mechanism for the significantly heavier hammers, as opposed to the marshmallows or pickup bag of last year. We also were using two cameras before, a large main camera and a small side camera, as you see here. But we now changed to a single camera on a gimbal mechanism, which was much more reliable and much easier. We've also reprinted all of these parts in ABS, which is lighter and stiffer. And then hand it off to Eugene for software and flight testing.
Now, hardware wasn't the only thing that we changed on this drone. There were a lot of software changes as well. And I could go through line by line and explain to you what each line was, did, and how it changed. But I didn't want to do that, and you guys definitely don't want to hear that. So I'm going to use a lot of images. So first, I want to talk about the improvements. Last year, we used the OpenCV model. To be able to detect and read the QR codes. And as you can see on the screen right here, That did pretty well. It was able to both detect and read the model, and even identify the target for the pilot to be able to easily read it on their screen. However, during additional testing, we had many issues with this, including the fact that it couldn't really detect and read the QR codes at further away because the QR code was so small. And additionally, whenever we started to lose video transmission, it was really hard for the model to be able to pick it up with the grainy images. And that's why we decided to switch. This year, we used a YOLO model to be able to more easily detect the QR code from further away. This allowed us to get an accurate read and lock on the QR code from even further away and with even grainier images, improving our mission capability. Additionally, this allowed us to be able to achieve a precision landing, as you can see here, where the camera is able to detect where the QR code is relative to the drone and send adjusting movement commands to be able to center it and properly land on the QR code. And just to showcase how much the model improved from last year, this is a grid of 5 QR codes, labeled A through E. A being the clearest and E being the blurriest. QR code A. You can take out your phone right now and you can be able to scan that and read what it says on there. However, any subsequent QR codes, your phone is unable to read. As you can see on the left side of the screen, that is our model last year, and is only able to detect QR code A, the most clearest one. However, this year's model was able to detect all 5 QR codes, even the most blurriest one. This shows how much of a huge improvement we had on the model and being able to detect QR codes from grainier and further away images. However, all of these major improvements didn't come without their downsides. One of them being the high computing resources needed to be able to process this new model. If you can see on the left side of the screen, the GPU usage is at 100% while I was running this model on my computer. And to put this into a little perspective for you guys, my computer has an RTX 3050 as shown right here. That's a pretty beefy GPU. And what we needed this model to run on was a Pi 5 as shown right here. And to better put into perspective the differences of the computing capabilities of these two machines, this is a Pi 5 in scale next to the RTX 3050. And that's especially surprising considering that this is just a GPU and that's the whole entire computer. Obviously, we didn't have enough computing power on the drone to be able to process the new model. That's why we decided to move the code off of the Pi onto the ground station computer where we could control it with a much bigger computer, allowing us to run the model more smoothly. However, this also wasn't the only issue that we faced with our new drone. One of the many pressing issues was with our new digital camera. The digital camera we acquired was for FPV pilots. This had a really wide field of view to allow those pilots to be able to see a lot on their screen. However, it was a very negative side for us because it tended to distort things. This QR code you see on the screen is a square box, and that pickup mechanism is supposed to be straight. Obviously, neither are straight. This caused a lot of problems in us being able to read the QR codes since all the distortion confused the model into not being able to actually read them properly. And that's why, with some undistorting code and some improvements to the model later, we were finally able to reliably read the QR code, as you can see here, where we detected that that QR code was reading the bent nail claw. This also wasn't the only improvements that we made from last year. We additionally added additional code like this menu that allowed the ground station controller and the pilot to be able to remotely arm, take off, mark GPS coordinates, fly GPS coordinates, and land with just one click. This allowed us to have autonomy throughout the entire mission, from arming the drone, taking off, flying to mark GPS coordinates, precision landing, taking off again, and flying to another target. Now, I'm going to hand it off to Judah.
So go, no-go procedures is like another checklist for us. So number 1 is swollen LiPo batteries. If they are damaged or puffy, that can cause a major risk to the drone and personnel because they can catch fire or disarm the drone because of fail-safes. Number 2 is bad weather. Since Oshkosh this time of year is notorious for bad weather, we've actually had many tents cave in and be flooded. So obviously we wouldn't fly with that, and I wouldn't think the competition would be going on with that kind of weather going on. Number 3 is airspace restrictions. Since we are at the largest air show in the world, we have a very tight and small airspace to fly in, and we have geofences to keep us within that airspace. Number 4 is unable to connect to the RC transmitter. Obviously, like previously mentioned, I am a failsafe if anything goes wrong. So if that can't connect or for some reason doesn't work, that's obviously a issue, and we will try to fix that before we fly. If we can't get that fixed, we won't fly. Number 5 is loose parts or equipment. If anything's cracked like shown on the screen, or loose like a leg or a motor, that would be an issue. So we wouldn't fly, we would fix it, then fly. Number 6 is crew fatigue. Like mentioned, we have worked very late and very hard some nights. And last year that caused us issues in the field at the actual competition. So this time, like mentioned, we have a bedtime and we have followed that. That worked very well. Number 7 is lack of communication. If one person does something the other person doesn't know about, that can cause problems immediately or later on. Number 8 is malfunctions. Like mentioned, we are going to use a lot of automation, so that can have issues, errors, all that kind of stuff. So we look over it, make sure everything looks fine, fix it if it doesn't. If it doesn't work, then we won't fly. Now I'll demonstrate voice commands. Clear props! Barrel on! Arming! Armed! Moving to waypoint! Eyes up! Eyes down! Barrel off! Take over! The voltage is taking off! Landing! Mark! Mark found! Target! Target! Return to launch! Disarm! Power off! Abort! Abort! Abort!
And I want to talk about some of our personnel resourcing. So I don't know if you've seen, but we have a little bit of a smaller team than a lot of the other teams. So we only have 6 people here in Oshkosh. So we have to make sure that we're very optimal with the way that we're using our personnel. So firstly, we have Cole and I. We both do ground station. So we will be behind the table the entire time, usually in front of a laptop or in front of a monitor, reading off the voltage, reading off the altitude, and reading off any mode changes to make sure that we have optimal communication to the entire team and everyone knows what's happening. This is especially important when we have the drone going off out of line of sight and it could go behind a tree or go under a building, and we want to just make sure that we know what's going on with the drone and there's not going to be something funky that happens. We next have Brody and Jeremy. They will both be working hands-on with the drone, both wearing these orange vests. They will be generally the only people on the flight line with one exception that I'll talk about a little later. So they will be changing out batteries, putting on the props, setting up poles, setting up all of that stuff. And we want to make sure that they have that safety and they're like the only people who will be beyond the table on the actual flight line. We next have Judah. Judah is our pilot. He will be behind the table with the ground station looking at the camera feed on our laptop. Kind of self-explanatory, he is our pilot. And then lastly we have Eugene. Eugene will also be wearing an orange vest, but he is behind the table generally working on software, and he'll be making sure that we get the camera up and running and all of the software running. Just running that because he knows what he's doing. And then he's also a floater, so if they need some help on the field, he'll be able to go float. And that's how we kind of manage our smaller team. As you can see, we've done a lot this year. We've accomplished a lot, and I'm super proud of my team. From even the simple stuff like our proof of flight and the pilot and ground station training to a little bit more complicated stuff like our flight testing, and then the pretty intensive stuff like the new hardware installation and the software installation and testing. We've accomplished a lot, and I'm super proud of our team and proud and thankful for the opportunity to compete. Do you guys have any questions?
Great presentation. Thanks, you guys. Questions from the judges?
What did you find as the most difficult part of the mission?
I would say visualizing what we needed to see with the camera was the most difficult part. We've changed cameras several times this year and have finally settled on the gimbal with the FPV camera.
Did you consider any different like aspect ratio lenses for that FPV camera where you can change those out and adjust the field of view?
We did have several lenses that we tried, but most of them had other problems such as focusing or being too dark or too bright.
We've got some people that are graduating out. So you guys ready to keep this team going and bringing in those new team members?
We have our eyes on a few people, but we'll see.
Okay. Good deal. So given that you have quite a depth of experience within the team, you've got several members at 4 years, 3 years, 2 years, lots of returners. What do you think is the key to retaining those individuals on the team and continuing the sustainability of that experience?
Yeah, I think a lot of it is our camaraderie. So, yes, we're working very long days. These past few weeks, we've worked 12 plus hours on our drone for most days. But we work really well as a team together, and then we also allow time for funny moments like pizza deliveries and going to Walmart and trying to find going to 3 Walmarts trying to find the correct part and stuff like that. So we can still have fun as a team, and I think that's really the key. Is we love our team, and so it's not just slaving away coding, slaving away tying screws. We're not super toxic to each other, and I think that since we really love what we're doing and we love the environment, it's really easy for us to come back.
What do you think is the best experience for your team, specifically the individuals here, about having this final competition at AirVenture?
I think that it's really cool to have the opportunity to fly at the biggest air show in the world, understanding one, how airspaces work, and making sure that having the ability to fly in our restricted airspace and making sure we don't go outside of that, and then also just being able to experience AirVenture and see all of the aviation outside of just drones.
And I'd like to add that because we're at such a very chaotic environment with a lot of things going on, with us sleeping in tents, with there being a lot of people around, it just kind of adds a new layer of sticking together, where we're all in a new and chaotic environment, and we are with the people that we know and we trust, and it kind of increases that camaraderie throughout the way.
Good deal. Other questions? Thank you for your presentation. It's been great.
Great job.
Yeah.